All right, so we're going to be doing some more factoring quadratic trinomials. And the thing that I love about this is even though a lot of people have trouble with it, if you really just relax about it, it's only 5 cases. I'm going to give you 4 today, but you've done 2 of them. So let's take a look. Let's review the previous 2 cases that we've learned. So the first case is, what if I give you x squared plus bx plus c? In other words, the b is positive and the c is positive. What this means in general is you're trying to figure out what multiplies to a positive c and adds to a positive b. Okay, what I like to do is go cover up the right column and say, how do I multiply to get a positive number? Well, the 2 numbers can be positive positive or negative negative. So a positive times a positive would make a positive. A negative times a negative would also give you a positive. But if I add 2 positives together, I get a positive. If I add 2 negatives together, I do not get a positive. So the combination in case number 1 is if I multiply to a positive c and add to a positive b, that means that the combination must be positive times positive. And just to give you guys an example on the right, and I'm going to use the same 2 numbers over and over and over again. So in this case, hopefully you guys will be able to do this without a table. What 2 numbers multiply to 14 and add to 9? I should rephrase that. What 2 numbers multiply to positive 14 and add to positive 9? Note that it is a positive-positive combination. The answer is positive 2 and positive 7. So that can be broken down into x plus 2 times x plus 7. Okay? Now, moving on to case number 2, which is what we did in the previous video. What if it's x squared minus bx plus c? In other words, we're trying to figure out what multiplies to a positive c and adds to a negative b. So I'm going to cover up the right column. How do I multiply to get a positive? Well, I could get positive times positive or negative times negative. So those are the 2 outcomes. However, if it adds to a negative b, that means that if I do positive times positive, positive plus positive does not add to a negative. But if I do negative times negative, negative times negative will make a positive, and 2 negatives added together will make more negative. So for example, using the same 2 numbers, what 2 numbers will multiply to positive 14 and add to negative 9? The answer is negative 2 and negative 7. Therefore, x squared minus 9x plus 14 can be factored into x minus 2 times x minus 7. Okay? So these 2 you've mastered according to the previous 2 videos. Please email me if you have any questions, though. This is my favorite subject to teach. My favorite unit to teach, rather. Moving on. So let's say I give you case number 3. Let me get my multicolored pen. So what if I give you, in this case, x squared plus bx minus c? So what does it mean if I have x squared plus bx minus c? Well, that means that I'm multiplying to a negative c, but adding to a positive b. I'm looking for the 2 whole numbers that satisfy this combination. Well, I'm going to cover up the right column and analyze this critically. Well, if I multiply to get negative c, in other words, the 2 numbers multiply together and get a negative. Well, positive times positive is positive. Negative times negative is positive. Therefore, positive times negative has to equal a negative. So in order to get through this, I'm going to show you an example over here. In other words, what two numbers are going to multiply to negative 14 and add to positive 5? Well, if it's going to be some sort of combination of 2 and 7, I want the bigger number to be positive. I want the positive to overpower the negative. So it's going to be x minus 2, x plus 7. You can FOIL it out to check your work. But the idea is negative 2 times positive 7 multiplies to get negative 14. However, negative 2 plus 7 has to equal positive 5. So what I'm going to put right here is if it multiplies to a negative and adds to a positive, that means that it's going to be a weak negative times a strong positive. So the bigger digit is going to be positive, and the bigger digit is going to be positive. The weaker digit is going to be negative because it has to add to be positive. Okay, so let's take a look at the last case. I'm going to get in this case, x squared minus bx minus c. So before I go into that general case, the same two digits, what two numbers multiply to negative 14 and add to negative 5? Well, spoiler alert, it's going to be some combination of 2 and 7. Remember that it has to be two numbers that multiply to a negative c and add to a negative b. Two numbers that multiply to a negative have to be one of each, one positive, one negative. So in this case, the negative has to be stronger than the positive. So the factored form is going to be x plus 2, x minus 7, because positive 2 times negative 7 is negative 14. Positive 2 plus negative 7 is negative 5. So if I can draw a general case for this, that means that if I want to figure out the combination, it's going to be a strong negative and a weak positive. Okay. There's a fifth case, but we're going to go over that in another day. But I really need you to know all four of these cases. Okay, so let's get on to some problems. Let's take a look at problem number 1. X squared plus 7x minus 18. I want to factor this into two binomials. So in this case, I'm looking for two numbers that multiply to negative 18 and add to positive 7. So I'm going to cover up the right column. How do I get two numbers that multiply to negative 18? Positive, positive, negative, negative, or one of each? The answer is one of each. Now I'm going to uncover. It's a positive-negative combination. Which one's going to be stronger? It's going to be a strong positive and a weak negative. So I'm going to do small negatives and big positives. Negative 1, positive 18. Well, negative 1 times positive 18 is negative 1 times positive 18 is negative 18. But negative 1 plus 18 is positive 17. That's not what I want. Okay, well, let me try dividing by 2. Specifically, I'm going to divide by negative 2. Negative 2 times positive 9 is negative 18. Negative 2 plus 9 is 7. We win. So that checks out. Therefore, x squared plus 7x minus 18 can factor into x minus 2, x plus 9. Let's take a look at problem number 2. X squared minus 4x minus 21. Okay, so what am I looking for on this table on the right? Two numbers that multiply to negative 21 and add to negative 4. So I'm going to cover up the right column and I'm going to look at this. How do I get two numbers to multiply to negative 21? Well, it has to be positive times negative. Now I'm going to uncover the right column. Positive times negative, but which one's going to be stronger than the other? Yeah, it's going to be a stronger negative. So a weak positive and a strong negative. So I'm going to do low positive, big negatives. Let's try 1 and negative 21. 1 times negative 21 is negative 21. 1 plus negative 21 is negative 20. Is that what I want? No. Let's try 21 divided by 2. Well, 21 divided by 2 is 10.5. It's a decimal, so forget about it. Let me try 21 divided by 3. Is that going to work? Yeah. So let me try 3 and negative 7. 3 times negative 7 is negative 21. 3 plus negative 7 is negative 4. We win. So therefore, how do we factor this? X plus 3, x minus 7. Okay, see if you can do these next three problems independently. Note, if there's no number in front of the x, we can put this 1 right there. Okay, I'm going to take a look at these one at a time. X squared plus 5x minus 24. So let's say I go to my table to the right. What am I looking for? I'm looking for two numbers that multiply to negative 24 but add to positive 5. So if I cover up the right column, I know that it multiplies to negative 24. So it could be positive, positive, negative, negative, or 1 positive, 1 negative. Yeah, it has to be 1 positive, 1 negative. But which is going to be stronger? Weak negative, strong positive. So let's list the suspects. Negative 1, positive 24. Negative 1 times 24 is negative 24. Negative 1 plus 24 is 23. That's not what I want. Can I do divided by 2? Yeah. Let's try negative 2 and positive 12. Negative 2 times positive 12 is negative 24, but what's negative 2 plus 12? Positive 10. Can I divide by 3? Yeah. So let me write down negative 3 times positive 8. Negative 3 times positive 8 is negative 24, but what's negative 3 plus 8? 5. We win. So the winning combination is negative 3 and positive 8. So therefore, this x squared plus 5x minus 24 factors into x minus 3 times x plus 8. Okay. Now, like I said before, I'm looking for two numbers that multiply to negative 12, and there's no number right here. So what do I do? Well, I could put this imaginary 1 here. If that makes me feel better, I can do that. So I'm looking for two numbers that multiply to negative 12 and add to negative 1. So I'm going to cover up the right column. How do I multiply to negative 12? Positive, positive, negative, negative, or 1 positive, 1 negative? 1 positive, 1 negative. I'm going to uncover the second column. Which is going to be stronger, the positive or the negative? The negative. So therefore, I'm going to start writing weak positives and strong negatives. 1 times negative 12 is negative 12. 1 plus negative 12 is negative 11. That's not what I want. Can I divide by 2? Yeah. 2 times negative 6 is negative 12. But 2 plus negative 6 is negative 4. It's not what I want. All right. 3 times negative 4 is negative 12. 3 plus negative 4 is negative 1. That's what I want. That's the winner. So what this means is since 3 and negative 4 are the winning team, I can factor this into x plus 3, x minus 4. Now, same thing with number 5. X squared plus x minus 30. I'm trying to factor this into two binomials. I'm looking for the winning combination that multiplies to negative 30. Oh, I don't know why I didn't make that table all the way down. There we go. Multiplies to negative 30, and there's no coefficient, so I can put a 1. And adds to positive 1. I'm going to cover up the right column. Multiplies to negative 30 means positive, positive, negative, negative, or 1 positive, 1 negative. Right. 1 positive, 1 negative. But if it adds to positive 1, that means that the positive has to be just a little bit stronger than the negative. So let me write that table. So it has to be a weak negative and a strong positive. Negative 1 times positive 30. Negative 1 times positive 30 is negative 30, but negative 1 plus 30 is 29, positive 29, I should say. Can I divide by 2? Yeah. Negative 2 times positive 15. Negative 2 times positive 15 is negative 30, but negative 2 plus 15 is positive 13. Okay. Let me try dividing by 3. Negative 3 times positive 10. Negative 3 times 10 is negative 30, but negative 3 plus 10 is 7. That's not what I want. Can I divide by 4? No, 30 divided by 4 is 7.5. Can I divide by 5? Yes, in particular, let me get that a little bit room up here. I'm going to need a pen. Negative 5 times positive 6. Negative 5 times positive 6 is negative 30, but negative 5 plus 6 is positive 1. There's the winning team. So therefore, if negative 5 and positive 6 are the winning team, x squared plus x minus 30 is x minus 5, x plus 6. Now, I'm looking at all 5 of these problems, and I want to make sure that we're on the same page. Some of you guys might be asking, is it okay if I write x plus 9 times x minus 2? Yes. Is it okay if I write x minus 7 times x plus 3? Yes. Is it okay if I write x plus 8 times x minus 3? Yes. Is it okay if I write x minus 4 times x plus 3? Yes. And finally, is it okay if I write x plus 6 times x minus 5? Yes. But what I don't want to see are x minus 9 times x plus 2 for this particular problem. That would multiply to form x squared minus 7x minus 18. So let me just show you some quick examples. I'm looking at the clock right now, but I want to make sure that we're good with this. So for instance, dude, come on. Are you really going to be that picky? It's a positive and a negative. Well, just to show you, I'm going to FOIL the first two examples. So let's say I got x plus 2 times x minus 9, and I FOIL that out. That's going to be x squared, x times negative 9 is negative 9x, positive 2 times x is positive 2x, and positive 2 times negative 9 is negative 18. I'm going to combine the like terms in the middle, and that's going to get me x squared minus 7x minus 18. Versus what we put down, let's FOIL this out. X minus 2 times x plus 9. X times x is x squared. X times positive 9 is positive 9x. Negative 2 times x is negative 2x. And negative 2 times positive 9 is negative 18. If I combine the like terms, I get x squared plus 7x minus 18. Do you see the difference? The only major, sorry, the camera's out of focus. The only major difference is the middle term. If you want negative 7x in the middle, you would want a strong negative 9 and a weak positive 2. If you wanted a positive 7, you would want a strong positive 9 and a weak negative 2. Okay? And we picked x minus 2, x plus 9, because we wanted x squared plus 7x minus 18. Okay? I'm going to do one more because I'm looking at the clock. Let's say we did x plus 7 times x minus 3 versus x minus 7, x plus 3. You would get x squared minus 3x plus 7x minus 21. If I combine the like terms in the middle, that's going to get me x squared plus 4x minus 21. Okay? I'm going to compare that to the other set of binomials. If I distribute the x to the x, I get x squared. X times positive 3 is positive 3x. Negative 7 times x is negative 7x. And negative 7 times positive 3 is negative 21. If I combine the like terms in the middle, I get x squared minus 4x minus 21. Right? I'm looking at the clock. I just want to make sure you guys understand this. But yeah, you could do the same thing with these pairs on your own. But I just wanted to show you that the signs do make a difference. And I'm just going to throw a whole bunch of these problems at you in the next video. Okay? Email me if you have any questions.